All right, so here's our third and final example. So again, as I'm reading this word problem, I'm looking for the initial value and I'm looking out for the multiplier and whether I'm going to be adding or subtracting from 100%. So our third example says, a car purchased for $34,000 is expected to lose value or depreciate at a rate of 6% per year. Using X for years and Y for the value of the car, write the equation that models the situation. So right away, a car is purchased for $34,000, so that is my initial value. Okay. 34,000. Okay. And then the car depreciates or loses value at a rate of 6% per year. So that means that I'm going to start off with 100%. And then since it depreciates or loses value at a rate of 6%, I'm going to subtract. Since it depreciates, it loses value. So it's going to decrease by 6%. Okay. So we have our initial value and our multiplier. And so let's go ahead and start writing our equation. I'm gonna move that out of the way. So it's gonna be y equals A, our initial value, 34,000. That's how much the car is worth at the beginning. And then our multiplier goes in parentheses, and it's going to be 100% minus 6% because it's going to lose value. It's going to depreciate 6% each year. So we're subtracting 6% from 100%. So 100% minus 6%. And then, of course, once you close the parentheses, don't forget your exponent x outside of the parentheses. All right, let's simplify this. Y equals 34,000, and then 100% minus 6%, that's going to give you 94%. Okay. And then finally, we do not want this percent as a percent. We want it to be an actual number when we write our final exponential function. So to get rid of the percent, we write our decimal and we move it over twice to the left. 1, 2, and our new number, instead of a percent, we're going to have 0.94. Okay, that's going to be our multiplier when we write our final exponential function. So it's going to be y equals 34,000, our initial value, 0.94, our multiplier, to the power of x. And again, here we can explain whether this is growth or decay. Of course, it's decay. We already know that because we were subtracting 6%. It tells us that it's losing value. So we can kind of already figure out that this is decay. But we can also look at our multiplier, and we see that our multiplier is less than 1 and greater than 0. So it's in between 0 and 1. And that means that this is an example of, just like example 2, decay. Okay. Let's go ahead and look at our word problem one more time with our function so that we can make sure that we wrote that correctly. Right. So let's go ahead and read that through. So we are saying that the initial value is 34,000, which is correct. The car was purchased for $34,000. And then we have a multiplier of 0.94 or 94%. And that is also correct because it says that it is expected to lose value or depreciate at a rate of 6% per year. Okay, so that's why this is 94% or 0.94 because it's 100% minus 6%, which is equal to 94%. And then written as an actual number, that is 0.94. So that's how we got that multiplier, and we said that it was decay.